Okay, let's talk about section 1.6. Equations and inequalities involving absolute values. Okay, so remember that absolute value has the following definition. If you have a number without sign, it's just itself, like positive or zero. If you have a number with a negative sign, when the number itself is negative, you are going to add additional negative sign to balance, to cancel the negative sign. So the answer is positive. So absolute value function always take non-negative values. Okay, so you are not supposed to get absolute value of an arbitrary number equal to -2. That is impossible. Absolute value of x equal to -2 has no solution. Okay, so that's one of the important thing. The other important thing is that if you have absolute value of x equal to 2, it will give you two solutions. Because positive 2 has absolute value itself, and -2, after you cancel negative sign, you also have absolute value of -2 equal to 2. So absolute value of x equal to a positive number will have two solutions. Absolute value of x equal to 0 has only one solution. These solutions. X equal to 0 because there's no -0. -0 is still 0. Okay? So whenever you have absolute value of x equal to a positive number, you'll get plus a positive number and minus that. All right? So that's the important facts about absolute value function. Now let's see the example. Solve the equations. 1, we have absolute value of x plus 4 is equal to 13. Okay, well, whatever inside, it's like some integrated quantity. This integrated quantity has absolute value equal to 13. Then you have, it's positive, 13 is positive. You have two choices. Either this internal quantity is equal to 13, or this internal quantity is equal to -13. Okay, follow the second. Okay, and then you have two linear equations. You know how to solve linear equation. Just move 4 to the other side. It will get x is 9 or x is -17. -13 minus 4 is -17. So the solution set is 9 and -17. Okay, 9 and -17. Second, if the absolute value of 2x minus 3, the quantity plus 2 is equal to 7. Okay, so for this one, the first step, you have to move this 2 to the right side. So you move 2 to the right side, 7 minus 2 is 5. And then you're back to the first type. So you will get the internal stuff is equal to 5, or 2x minus 3 is equal to negative 5. Two choices. And then you move 3 to the other side. You get 2x is equal to 8, or 2x is equal to, it's plus 3, it's minus 2. Negative 5 plus 3 is negative 2. And then you divide the equation by the coefficient 2, you will get x equal to 4, or x is equal to negative 1. Okay, so the solution set is 4 and negative 1. 4 and negative 1. Okay, so that's our equation involving absolute value. You just leave absolute value in one side and consider the other side as a number, and then you have two choices based on the number. If a number is 0, you have just one choice. If you have a non-zero, a positive number, you have two choices. Okay. All right. Let's see if we can find more interesting examples. Okay, yeah, let's do more examples. 3, it's on page 133. Let's see problem 24. If we have 5 minus absolute value of 1/2 x is equal to 3. So how do we do that? We're going to move this absolute value to the right side, 3 to the left side. You will get 5 minus 3 is equal to absolute value of 1/2 x. And 5 minus 3 is 2. Absolute value is 2, then 1/2 x is 2, or 1/2 x is negative 2. It doesn't matter you put number left side, absolute value right side, or you switch them. You always have two choices for the positive numbers. So x is 4, or x is negative 4. Okay, so solution set is 4 and a negative 4. Right? And let's see another one. Yeah, 32. On the same page, 133. 32. If we have absolute value of 2x plus 1 over 3x plus 4 equal to 1, then what we do? We have 2x plus 1. Well, inside internal function is very complex, whatever. It is equal to 1, or 2x plus 1 over 3x plus 4 is equal to negative 1. Whenever you have absolute value, when you try to remove it, you will always have a positive and a negative situation. Okay, and then you multiply this equation by 3x plus 4. Here's the same thing. You multiply this equation by 3x plus 4. Negative 1 times 3x plus 4. Negative 1 times 3x plus 4 is negative 3x and minus 4. Okay? And then you have two linear equations. Let's solve them. So 3x to the left side, 1 to the right side. You get a negative x, 2x minus 3x, negative x. 4 minus 1, 3. Negative 3x to the left side, 1 to the right side. 2x plus 3x, 5x. You move to the left side, it becomes plus positive 3x. Negative 4 minus 1, negative 5. And here x is negative 3, or x is negative 1. So solution set is negative 3, negative 1. And for this one, you need to check the denominator. 3x plus 4 is non-zero, is not 0 for x equal to negative 3 and a negative 1. Then you can get it because you have denominator. Whenever you have denominator expression, you must verify if you get the correct, if your answer is the original equation. Okay? Whenever you have a denominator of the expression, you must verify it. All right. Let's see another one. This one is more complex. 34. 34, we have x squared minus 2x. X squared plus 6x. You have ops value function is equal to ops value function. You want to remove the ops value. Like you have a left hand side with ops value and right hand side with ops value. Two things, you see here, two things have the same ops value. Then they are almost equal, but sometimes they have opposite sign. So this situation is equivalent to possibly they are the same, or possibly they have the different sign only. So absolute value of fx is equal to absolute value of g of x. Then either fx is g of x or fx is negative g of x. Okay? So here, let's check. The left side is x squared minus 2x. It is either equal to x squared plus 6x or x squared minus 2x is equal to negative. This negative is for the whole function, so it's better for you to put parentheses here. So x squared minus 2x is equal to x squared plus 6x, or x squared minus 2x is equal to negative parentheses x squared plus 6x. All right, so two things have the same ops value. They are almost the same, but possibly with a different sign. Okay, now let's check x squared. You have two quadratic equations. Let's check if you really have quadratic equation. X squared, you cancel them. So you move this 2x to the right side, you get 0 equal to 8x. Or here, it is x squared minus 2x minus is equal to x squared minus 6x. Okay, and 8x equal to 0, then x is equal to 0. In this one, you move to the right side. So x squared, here you move to the right side, is plus, it's 2x squared. Here's minus 6x, move to the left side is plus 6x, minus 2x plus 4x is equal to 0. Okay, let's continue. Here we already solved this branch. Let's keep this. Here we factor out 2x. We factor out 2x, we get 2x times x plus 2. So either 2x equal to 0, then x is 0. Or x plus 2 is 0, x is negative 2. So you see how x equal to 0, x equal to 0, x equal to negative 2. So the solution set will be 0 and negative 2. This is repeated. In the solution set, we do not repeat the numbers. All right, so this is the answer, the solution set. And this problem is a little bit more difficult than the previous one because you have two ops value of a function. Okay, keep this in mind. It's important, more difficult. All right. Okay, so we had 3 additional example. I hope this is enough. Just try to do the exercise. If you have question, we can continue the discussion on this. We can give more examples. Okay, so this is an equation involving absolute value. Well, let's see the inequality. Inequality, the first thing, let's check what is ops value of x is less than 2. Remember, in the number line, first, let's study what is ops value of x is equal to 2. In the number line, we already mentioned that this absolute value of x is equal to 2. You have two solutions, 2 and negative 2. And this absolute value actually measure the distance between the input between the x and the 0. Okay, whenever you have absolute value of x, you have x here. Then what is the distance between x and 0? This distance is absolute value of x. Always. It's on the left hand side, the distance is positive. If you put on the right side, the distance, of course, is still positive. Okay, so that's the distance explanation about the absolute value. Just the distance. Okay, and then once we understand this, let's consider what is the meaning of a absolute value of x less than 2. Less than 2 means it's close than 2, right? So, for example, for this one, which point is has a distance distance to the origin less than 2? Well, this part. Every point from this region will have distance to the origin less than 2, right? So the absolute value of x less than 2 has the solution set. X what? X should be bigger than -2 but less than +2. Right? It should be included in this interval. In other words, it says interval. This interval comes from the observation of the distance. This distance to the origin is shorter than the distance between 0 and 2. Shorter, less than. Okay? So if you have equal sign, means it could be 2. The distance could be 2, which means we should include those two endpoints. It has the solution set. -2 and +2, but you should use closed interval. Closed interval. Those two endpoints inclusive. Here, open interval means you do not include endpoints. This is strictly less than. If you have equal, it is less than or equal. It's those two closed interval. Okay, so to summarize these two observations we have for a positive number, like this number 2, number a. This is a. I let number a. For a positive number a, absolute value of x is less than a, has the solution set. Negative a and positive a. Okay? The distance is bounded by negative a and positive a. And similarly, this is 1, this is 2. If we have less than or equal to, it has the solution set. Negative a and positive a, inclusive. Solution set is is like this. In other words, we say 1 prime. Absolute value of x less than a is equivalent to x between negative a and positive a. Is equivalent to this condition. This condition will give us solution set. That's another way to say it. It is equivalent to this. And the second absolute value of x is less than or equal to a is equivalent to x is between negative a and positive a, but with equal sign. Okay, so absolute value inequality less than a means the distance smaller. This distance, this interval. All right. Well, let's draw it here again. These 2 points has distance exactly 2. Inside, less than 2. What about outside? This part, the distance will be greater than 2. This part, the distance will be also greater than 2. Right? For example, if you choose number 3, the distance between number 3 and the 0 is 3, is greater than 2. If you choose negative 3, the distance between negative 3 and the 0, of course, is 3. It's also greater than 2. All right? So absolute value of x is greater than a. Greater than 2 is equivalent to those 2 branches. Those 2 branches, one of them, if one of them happens, then it's correct. So here is all. The situation is the union. You have to consider the union of those 2 branches. Okay? So this one is equivalent to x is either too big or x is too small. Okay? X is either too big on the right side or x is too small on the left side. So x is either greater than a or x is less than negative. Remember, we consider a positive a. We always consider a positive a. All right? And if you have equal sign, it is equivalent to x is either greater than or equal to a, or x is less than or equal to negative a. You just put the equal sign in the corresponding place. All right, so that's the observation, the abstract observation. Abstract observation. Now let's try to study. Well, by the way, here, what happened if a is 0? Here we always assume a is positive. For 0, absolute value of x less than 0. Remember, absolute value of x can never be less than 0. This one has no solution. Well, if it's less than negative number, it does not have solution either. What happened? Absolute value of x is less than or equal to 0. Well, absolute value of x could be 0. Then it is equivalent to x equal to 0. Only 0 satisfies this condition. Only 0 satisfies. Okay? So this is a two extreme case. One case has no solution. The other case has one solution. And this part you always have the intervals. Good. Let's see the example. Solve the equation inequality, not equation. The inequality. Solve the inequality. Absolute value of 2x plus 4 less than or equal to 3. Less than or equal to 3. Remember, whenever you have absolute value less than or equal to a number, remember it's close, it's compact, it's smaller, it's between two numbers. Okay, so this one The internal stuff, whatever how complex it is, it should be bounded by -3 and +3. The distance is small. The distance is small. It's always bounded by -3 and +3. So this is a combined inequality, right? In this one is a combined inequality. We know how to solve a combined inequality. How did we solve the combined inequality? We subtract 4 for all three parts to cancel this part. Subtract 4. Subtract 4. Subtract 4. Okay, 3 minus 4. -3 minus 4. This part minus 4 cancel. And then we divide the inequality. Divide the inequality by 2. All three parts divided by 2. This is a positive number. You still have less than. Okay, well, it's done. The solution set is -7/2 and -1/2. That's it. So absolute value less than a quantity is equivalent to a combined inequality, and combined inequality will give you an interval, open or closed, just one interval. All right? It's closed interval because you have equal sign. If there's no equal sign, you're supposed to get an open interval. Let's check this. Solve the inequality. Ops value 1 minus 4x less than 5. Okay, so absolute value less than a positive number. Then it is internal stuff is less than 5 and greater than -5. Okay, and again, it's a combined inequality. How do we do that? We subtract 1 for 3 part, -6, -4, -4. 1 minus 1 disappear. And then we're going to divide the inequality by -4, because here the coefficient is -4. We're going to divide the inequality by this coefficient. Because you're going to divide the inequality by a negative number, you're going to change the inequality. 4 over -4, -1. -4x over -4 is just x. The purpose is to cancel the coefficient, so you should have x here. -6 over -4. Negative canceled is 3/2. See it? And then we prefer to use smaller number, x larger number. So we change the direction. So -1 less than x less than 3/2. So solution set is parenthesis -1 and 3/2. Be careful. In the solution, if you have an equation, you use this parenthesis, you can write 1 3/2 or 3/2 -1. They're the same thing. If you just mention 2 points, 2 numbers in the solution set, it's the same thing. But if you try to use the interval notation, -1 3/2, correct. 3/2 -1, wrong. We don't have such interval. Interval is always from smaller number to a large number. Okay, so be careful about the writing. This one is right one. This one does not make sense. All right. Okay, so this is a less than case. Now let's check a greater than case. Greater than. Remember, greater than has two possibilities. Either it's too big or it is too small. They are not close to the origin. Okay, so solve the inequality. Solve the inequality. What inequality? Inequality, ups value 2x minus 5 greater than 3. Greater than 3. Okay, so ups value is greater than 3. It's either on the right side or on the left side. So you have either 2x minus 5 is too large, greater than 3, or 2x minus 5 is too small, less than negative 3. Here you have to change it to be negative 3. Okay, so you have two inequalities separate. This is separate. This is not combined inequality. Okay, this is separate, two separate parts. You are going to use all. Okay, so 2x minus 5 greater than 3. We'll move 5 to the right side. So 2x is greater than 8. My bad. 8. 3 plus 5, 8. Here we move 5 to the right side. 2x is less than negative 3 plus 5 is 2. Less than 2. 2x is greater than 8. X is greater than 4. We divide inequality by 2. X is greater than 4. 2x less than 2. X is less than 1. We also divide it by 2. Okay, so either it is greater than 4 or it is less than 1. So the solution set is less than 1, negative infinity to 1, greater than 4, 4 to positive infinity, or this is symbol or in the interval notation, or. Okay? Well, for this one, you can write it this way. This is okay. You write who, this is called union. Union. It doesn't matter who union who. Okay? They're both correct. You don't worry about the order. But when you write interval, you must write from a smaller number to the larger number. All right? Well, let's see this is several provided example in the textbook. Now let's try to do more exercise from the exercise part. Exercise part, let's check, for example, same page on the page 133. Let's see problem. Okay, start from the simple one. Problem 38. Problem 38, ups value of 2x is greater than 6. Okay, simple. So either 2x is greater than 6 or 2x is less than negative 6. Greater than, two parts, less than the middle part, combined. Okay, then divide the inequality by 2, you will get x is greater than 3 or x is less than negative 3. So the less than negative 3, negative infinity to negative 3, or union greater than 3, 3 to positive infinity. Right? 44. Ups value of 3x plus 4 is greater than or equal to 2. So it's 3x plus 4 is greater than or equal to 2, or 3x plus 4 is less than or equal to negative 2. Right? Because it's greater than. Whenever I have greater than, it always contains two parts. Okay, so 3x is greater than or equal to negative 2. You move 4 to the right side. 2 minus 4 is negative 2. Or 3x is less than. So negative 2 minus 4 is negative 6. And divide the inequality by 3. So x is greater than or equal to negative 2/3, or x is less than or equal to negative 2. So negative infinity to negative 2, union negative 2/3 to positive infinity. Greater than right side, less than left side. Okay, let's see, 50. Ops value of a negative x minus ops value of 4 less than or equal to 2. Well, before we do whatever stuff, we need to simplify it. Ops value of 4 is 4. Actually, absolute value of negative x is absolute value of x, because, well, absolute value will try to ignore the negative sign. If you have it inside, eventually it will be ignored. So absolute value of x is equal to, absolute value of negative x is equal to absolute value of x. Okay, but whatever, you know or you don't know this, it doesn't matter. If, let's check, if you don't know this, move 4 to the right side is 2 plus 4 is 6. If you know it, you will have this one, okay? So two cases, let's see if we really have the same answer. But keep this in mind, this is correct. Okay, and then remember, it's less than is equivalent to the combining inequality. So you will get the negative x is less than or equal to 6 and greater than or equal to negative 6. And here x is less than or equal to 6 and greater than or equal to negative 6. Well, here is already solved. The solution set is negative 6 to positive 6, closed interval. Here you still have negative sign. You're going to divide the inequality by negative 1. But since you divide it by a negative number, you will change all the inequalities reverse. Okay? So negative 6 over negative 1 is 6. 6 over negative 1 is negative 6. Well, you write it in the traditional order. It's the same thing. Okay, it's the same thing. It doesn't matter if you have, if you know this property or not. But keep in mind, this is the right property. And be careful about this one. This property, we only have a negative of x. We don't have anything else. Be careful. These two are different. Why? This negative sign only controls x, but it does not control 1. If you really want to do that, you must factor out x. And then you're going to consider this stuff as an unknown quantity. Then you can drop this negative sign. This is the right one, but this is wrong. Here I only have one term, it contains x. Here I have one big term, it contains x. It contains negative sign, okay? Contains negative. So be careful, this is incorrect. This one is correct. If you want to cancel the negative sign, you have to make the negative sign in front of a whole term, not just the one term. All right? Okay, what else? Okay, 60. 3 minus ops value of x plus 1 less than 1/2. Well, first let's simplify it. We move this ops value to the right side, 1/2 to the left side. So 3 minus 1/2. 3 is 6/2. Minus 1/2 is 5/2. Is less than ops value of x plus 1. Okay. Well, let's write it in the traditional order. Left side contains x. So its ops value greater than 5/2. So you get x plus 1 greater than 5/2, or x plus 1 less than negative 5/2. So here x is greater than 3 halves, move 1 to the right side, 5 halves minus 1, 3 halves, or x less than negative 5 halves minus 1, negative 7 halves. So the solution set will be negative infinity to negative 7 halves union 3 halves to positive infinity. Okay, so well, this is the section of equations in inequalities involving absolute values. Equations are not difficult. The inequalities has two serious parts. Less than a positive number, you have a combined inequality. Greater than a positive number, you have two opposite. You have two opposite branches, right branch and left branch. Just don't mix them. Okay, so do your exercise. If you have any questions, send me email. If I made whatever mistake in the video, just let me know. Okay, thank you very much. We finish this video and we will continue the lecture in the next video.